Here's a beautiful number theory problem I'm super excited to share with you. The number 2 power 29, an absolutely massive number, we are told that it has 9 distinct digits. And we want to find out what is the missing digit. Now remember, the digits are going to be basically of any number are 0, 1, 2, all the way up to 9. So of course they're going to be 9 here, and then 0 is 10 digits. So one digit is missing because we're given 2 power 29 has 9 distinct digits. How are we going to find it? I'm a professional mathematician. I'm going to walk you through the thinking process behind this. And it's so beautiful. Now what we're going to do is we're going to think about the remainder when you divide 2 power 29 by 9. And you'll see why. Okay, this is a very creative observation. We're going to look at 2 power 29 and we want to say what is the remainder when you divide by 9. Now in math this is called modular arithmetic. We're asking it what is it congruent to mod 9. Okay, so this blank is going to be 0, 1, 2 up to 8. Okay, so it could be any remainder 0, 1, 2 up to 8. That's the remainder when you divide by 9. What is that number? Now here's one way I like to think about it, is just to look at a pattern. 2 power 29 is absolutely massive, so we don't want to calculate it. We want to actually find a pattern. So one way of finding the pattern is as follows. Look at 2 power 0. Okay, 2 power 0 is 1 mod 9. Okay, 2 power 0 is 1 mod 9. 2 power 1 is of course 2 mod 9. Now what this means is that 2 power 0 is 1, 2 power 1 is 2, so the remainder when you divide by 9 is 1 and 2. Okay, there's nothing there. I'm not really saying anything about remainders, I'm even saying equalities here. Now we can keep going. 2 squared is going to be congruent to 4 mod 9. This just means the remainder is 4 when you divide by 9. Again, it's entirely obvious because 2 squared is just 4, and similarly 2 cubed is going to be 8 mod 9 because 2 cubed is literally 8. What gets interesting is when you take 2 power 4, which is 16. Now 16 when you divide by 9, the remainder is 7. Okay, so then we say 2 power 4 is congruent to 7 mod 9. Now we keep going. 2 power 5 is 32. Divide by 9, its remainder is 5. So we get 5 mod 9. Okay, now we can keep going with this and you'll now see a pattern. When you get to 2 power 6, that is 64, divided by 9, 63 is a multiple of 9. So divided by 9, the remainder is 1. 2 power 6 is congruent to 1 mod 9. Now, what happens is that this pattern actually keeps repeating. When you get to 2 power 7, you have 1, 2, 4, 8, 7, 5, 1. You then repeat. You again have 1, 2, 4, 8, 5, 7, 5, 1, etc. So the next remainder, 2 power 7, will be, remainder when you divide by 9 will be 2. The way we justify this rigorously is we do what's called modular arithmetic. So when you multiply numbers and take their remainder when you divide by, say, 9, it's the same as multiplying their remainders. Okay, so when you take a massive number like 2 power 29, we know that 2 power 6 is 1 mod 9. That's a nice number. So 2 power 29 is equal to 2 power 24 times 2 power 5, right? So that's an equality. And if we just say these are all congruent modulo 9, and then 2 power 24 is equal to 2 power 6 power 4. Okay, times 2 power 5, which is 32. Now 2 power 6, when you take the remainder when you divide by 9, it's actually just 1 as we just saw. So what you could do is you could say this is 1 power 4 times 32. The remainder when you divide by 9 is just going to be 5 because 27 is a multiple of 9. So you just get 5 modulo 9. And that's what you get. So you just found out the remainder by doing this trick. You're just doing everything, taking remainders and then multiplying is a lot easier than multiplying out the numbers and then taking the remainder. Okay, so that's what we've done. This is what is called modular arithmetic. You can actually verify the pattern. I'm interested to see how you think about this, how you think about this. And I'd love to hear your approach, how you'd find the remainder when you divide 2 power 29 by 9. But that's what we get, is we get 5 modulo 9. And don't forget to hit that like button. Now we're going to get to something really juicy. Okay, we're going to actually now find what the missing digit is. So don't forget to hit that like button and subscribe if you're really enjoying the content. I love doing number theory on my channel and I've got so much fun content for you. So let's now get into finding out what the missing digit is. Now, why am I taking remainders when you divide by 9? That may be a question you're asking about. And this is based on a very famous divisibility test, that a number is divisible by 9 if the sum of its digits is divisible by 9. Okay, so I'm going to actually write that down. All right, so here we have the statement. A number is divisible by 9 if and only if the sum of its digits is divisible by 9. So it's a quick way to determine if a large number is divisible by 9. So you may have heard of this, but I will explain to you something that's even stronger than this, which is actually that a number is congruent to the sum of its digits modulo 9. So what do I mean by this? Let me actually explain this. So a number, so I'm just going to write this out in a kind of pseudo-mathematical notation. The number, whatever the number it is congruent to the sum of its digits modulo 9. And what that means is that when you take the remainder, when you divide the number by 9, it's the same as if you take the remainder when you divide the sum of its digits by 9. And that explains this test above. Because basically the number is divisible by 9 if and only if its remainder is 0 when you divide by 9, and that's the same as saying that the sum of its digits is the remainder is 0 when you divide by 9, and what that means is that a number is divisible by 9 if and only if the sum of its digits is divisible by 9. But this is a more general statement that says the remainders when you divide by 9 is always the same for any number, not just numbers divisible by 9. And how do you actually explain this? How do you actually explain this? So here's the explanation. Imagine our number in decimal form, okay? So what I mean by that is like, these are the digits of the number, x0, x1, dot, 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 xn. These are the digits of my number. So for example, this could be 78921 or whatever. Okay, I'm just writing it as digits. This is not a product of variables, it's just the digits, xn up to x0. Now, when you actually expand this out as a number, you write it out as a number, what is that equal to? Well, that's equal to x0 plus, this is the tens digit, x1. Okay, so it's going to be 10 times x1. This is x2 is going to be the hundredths digit. Okay, so it's going to be 100 or 10 squared times x2, and so on and so forth up to 10 power n times xn. So that's what the number is equal to. Now, if we try to add the sum of its digits, add up the digits, we're just going to add up x0 plus x1 up to xn. Okay, we're not going to actually have this 10 or whatever, 10, 10 squared. We're just adding up the digits because these are literally the digits of the number. So you have xn plus dot, dot, dot plus x0. Okay, that's the sum of its digits. We want to show that this number and this number have the same remainder when you divide by 9. How are we going to do that? It's so beautiful. To show that two numbers have the same remainder when you divide by 9, you have to show their difference is divisible by 9. So what is the difference between these two numbers? So the original number we saw is x0 plus 10x1 plus 100x2 plus dot 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 all the way up to 10 power n xn. That's our number. If we expand it out, those are the digits of the number. That's the actual expression for the number. And similarly, if you add up the digits, you're going to get x0 plus x1 plus x2 all the way up to xn. Now, if we take the difference between the two numbers, we want to show that's divisible by 9, and that will show that a number is congruent to the sum of its digits modulo 9. They have the same remainder when you divide by 9 because their difference is divisible by 9. And why is their difference divisible by 9? Well, you actually take the difference, you can cancel, so you can cancel x0, x1, and then you're going to get 10x1 minus x1 is 9x1, 100x2 minus x2 is 99x2, and you can keep on going all the way up to n nines. Okay, you're going to have n nines, so I'm going to say n nines times xn. Okay, so that's our number, and of course this number is divisible by 9. It's 9 times, you can factor out a 9. You can literally say that this is going to be 9 times x1 plus 11x2 plus 111x3 all the way up to 1 dot 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 1 n of them, n ones of times xn. Okay, so it's divisible by 9. So what this tells us, and now we're going to get to the final argument. I'm keeping the suspense. We're now going to get to the final argument. I just wanted to give a huge thank you so much to the supporters of the channel, Alex and Stephan for ongoing Ruby support on Patreon, and Nathan for ongoing Gold support on Patreon, as well as Aman, Rob, Bernard, and Shabeed for ongoing YouTube channel membership. Please consider supporting the channel by clicking the join button underneath the video for a YouTube channel membership, or checking out the link in the description for a Patreon membership. It makes a world of difference. There are exclusive perks, including priority reply to YouTube comments, a personalized thank you message, a members only Discord server, and so much more. I really am so grateful for all the support, and it drives the channel forward because I do everything on my own. So I just wanted to thank everyone who is currently supporting the channel, and let's now get into the video. Okay, so 2 power 29, we don't know what it is, but we want to look at the sum of its digits. Okay, the sum of the digits of 2 power 29. Okay, that's what we're interested in. So we are told some very crucial information here. Okay, in this problem, we have told that 2 power 29 has 9 distinct digits. Now we know that if you divide the sum of the digits of 2 power 29 by 9, the remainder is the same as if you divide 2 power 29 by 9. That's what we just explained. That for any number, dividing it by 9 and taking the remainder is the same as dividing the sum of its digits by 9 and taking the remainder. And we previously found, I've erased this now, but we previously found that 2 power 29 is actually congruent to, this is congruent to 2 power 29 mod 9, and we found 2 power 29, the remainder when you divide by 9 is 5. Okay, so that's 5 mod 9. Now one digit is missing, but let's think about all the digits 0, 1, 2, 3 up to 9. Okay, we don't know what is missing, but we know that if we take all the digits 0, 1, 2 up to 9, you add them up. What happens when you add up all those digits? If you add up all the digits, here's a quick way of doing it. 0 and 9 pair up, 1 and 8 pair up, 2 and 7 pair up. You see it's divisible by 9. because you can pair up it. 0 plus 9 is 9, 1 plus 8 is 9, 2 plus 7 is 9. So you're just adding up a bunch of things divisible by 9, so it's divisible by 9, or you could just add up all the numbers. If you add up all the numbers, you're going to get 45. If you just add up 0 plus 1 plus 2 plus 3 up to 9, you're just going to get 45. Okay, so you're going to get 45, which is divisible by 9. So what that tells us is the sum of the digits of 2 power 9 is congruent to 5 mod 9. If we add the missing digit, okay, if we add the missing digit, we're going to add all the digits, 0, 1, 2 up to 9. And we know that sum is going to be congruent to 0 mod 9. It's just 45, so it's divisible by 9. That means a missing digit has to be something you add to 5 to make it divisible by 9. And that number is 4, right? 5 plus 4 is divisible by 9. So the missing digit has to be 4. So therefore, which digit is missing? The answer is 4. That's the answer to the problem, and I just find this such a beautiful problem. And you can actually find the number, okay? The actual number, what is 2 power 29 equal to? It's equal to 536870912. So that's so cool, and you can actually literally see that 4 is the only missing digit from 0 through 9. But this problem did it without a calculator. No calculators allowed, and it's just so beautiful. And it's a beautiful application of number theoretic ideas. Now, I've got 2 fun videos for you. If you're enjoying this kind of math and you want to dive into it and learn a lot more about it, here are 2 videos you're going to love. The first video is this following beautiful question. It's really crazy. 67 factorial is 67 times 66 times 65 all the way times 3 times 2 times 1. An absolutely massive number. What happens when you take the remainder when you divide 67 factorial by 71? Can you actually figure out? This is a genius trick, and it's a 3-minute video. You're going to love this trick, and it's going to consolidate these ideas. Check it out. It's going to pop up on the screen here. You're going to love it. And another fun video you're going to love is what are the prime numbers p so that p squared plus 2 is prime? Prime numbers are so crazy. And this is a proof using basic algebra. I've got a complete solution for this using basic algebra. Again, a very short video. You're gonna love it. Check it out. It's gonna pop up on the screen here. Check out the playlist tab on my channel, the courses tab on my channel, and master whatever subject in math you love.